The 5th of April 2018. So Mark, today will be the day you start your individual project. I brought you out here for you to see the world from the top and use this thing you see here to cultivate your imagination and make something worth working for.
Yes! Oh my god, I don't know what to make! Help!
A few hours later.
I know what to make! I'll make a clock! Let's go! I have made the stand for the clock. Now all I need to do is make it work. The hands aren't working! Why? I'll try fixing it though. The hands still aren't working! I'm so tired, I will go to sleep.
Do not stop when you are tired. Stop when you are done.
Let's get to work.
Mark, what are you waiting for? Let's go.
Oh, I must have been daydreaming.
The end. So for the vertical lines, I use the equation x equals to a constant, and for this case it's minus 200. And then to make the line stop at some point, I use the special feature of Desmos, and it is to limit the domain and range of the line. And so as you can see, after I removed the domain and range, the line extends on forever, and now I'm adding it back, and as you can see, the line is now back to normal and it's restricted. And I also use linear inequalities to create the shading of the building. And as you can see, I also added the domain feature in order for the domain and range to be only at the limit of the building and not be extending forever as shown right now. So I'm adding it back, a domain back, and then as you can see, the building is back to normal. So here I use linear inequalities as well, but then I put it in a similar form to that of a domain in order for it to stop at some point, and the same applies to this side, the left side and the right side. And for the middle side, I only use the domain and range, similar as to the one with the building as I shown previously. And now we move on to the model of the teacher with orange hair. So first of all, we have his face. His face is made with the circle equation x minus k squared plus y minus k squared equals r squared, and I limited it to a y domain in order to cut off the chin. So to cut off the forehead to make the hair. So for the mouth, I use the equation of an ellipse to make the mouth, which is basically the same as the equation of a circle, but there's a denominator to show the inflation or the deflation of the mouth. For the x inflation deflation, I chose to use a 9 because I wanted the mouth to be wide, and I put k as the variable, and then I added a slider to it, which is a special feature of Desmos, which allows me to make the character open and close his mouth. I set k to be starting at 0.01, which is almost a straight line and a closed mouth, and I made it go to 4, which is basically an open mouth. And next, for the speech marks, I use two linear equations that intersects at the circle, which is basically the face, and I used an ellipse as the speech mark. And for the words that the teacher is saying, I decided to use a screenshot of my script instead of typing it out using the functions by hand because it will take too much time. And this is basically the same thing for the student, as you can see here. Now for this scene, which is basically the stand of the house, stand of the clock, I used linear functions with a slope to create the roof of the house, and I used x equals a constant and y equals a constant and a normal linear function to create the base, depth, and height of the stand. As for the circle, I used the circle equation with a center of 3 and 1 and a radius of 0.7. And for the singular Roman numerals, I use individual linear functions, one by one, one by one, one by one, to create each an individual number. and I limited them off with the domain and range in order for them to look like numbers. If I didn't use it, they would just be lines going everywhere. And as you can see that I'm scrolling through, you can see the equations that I have used for each of the singular numbers. And for the hands of the clocks, I use x equals 3 as a straight line and y equals x minus 2 as the hour line. So now for the scene where the main character is sleeping in his bed and he gets the dream with the quote, I used x equals a constant, two of them, to create the bed, and I used two inequalities, linear inequalities, to have a shading of the bed and show the individual colors with a domain and range, of course. And for this person's head, I use a circle equation, and I use five linear equations to show the person's body as shown there. And for the three circles, I use three circles in increments, as you can see, 1.4, 1.6, 1.8, 1.3, 1.5, 1.7, to show that they are going up diagonally and smooth. And I also made an ellipse using the ellipse equation. And now we're going back. We're now going to be checking on the quote using what functions did I use. So for the don't, I used one x equals a constant vertical linear line equation to make the D. And for the O, I used an ellipse equation to make the O, and I made the Y inflation, deflation more skinnier. And then for the S, I used a sine function, but I switched the X and the Y to create a vertical wave instead of a horizontal wave. And for the W, I used an absolute value of sine to make it go up and go down immediately instead of going up and going down like a regular wave. And it's the same for the H, but for the E, I use a circle equation and two linear equations. And for the R of your, I used a quadratic equation in the vertex form, a x minus h squared plus k, to make the R, and I limited it off using the domain and range. And for the pictures, or the tired and the done, I use pictures instead because I feel like they made a better effect on the audience rather than if I were to make them using equations from Desmos.